My name is Alfonso Tierno. I work for Telefonica. I am an active developer of OSM. I'm a leader of some core modules at LCM, Lifecycle Management, Resource Orchestrator, MBI. I'm going to have this 2 hours presentation, more or less. No, not so long. Well, I expect not so long. So it's a demo I'm going to present together with Gianpietro Lavado from Whitestad. So we have decided instead of having individual demos, having a combining demo to show some features of Release 5. So okay, the content is this. I'm going to make a short description and see the features we're going to show that are those related to physical network functions, day 1 and day 2 primitives using Ansible and BNF autoscaling. So let's start by the description before going the demo. We have already deployed a terminal, a client, in order to inject traffic. So that is this. Can you see that? Okay, this is the. I know you can see the. This pointer here. Okay, this is the client. We have also a physical element already deployed. It's a data center gateway. In this case, we are using BIOS to simulate this. Then we are going to deploy a hybrid network service consisting in a load balancing and a web server, and also using this physical element that we are going to configure with the day 1, day 2 operations. Later on, we are going to inject traffic to provoke this scaling, automatic scaling of the BNF. So firstly, let's just make a appointment of the physical network function, how it is used in OSM. Basically, there is, on one hand, we have the descriptors. Can be physical network function or hybrid network function, depending if all is physical or you combine in the same descriptor physical with virtual. In this descriptor, you don't say exactly or concretely what physical element to use. You just say, okay, I want to use an element of this type, just that. The type is something, it's a literal string managed by the OSM administrator. Okay, you have the declared interfaces, and you connect these interfaces to other virtual elements or to other elements. No? And you also declare the configuration, how this physical, once all is deployed, how these physical are going to be configured. On the other hand, you need to feed OSM with the physical data unit. Okay, you need to say, okay, the physical data unit that we have in the system are these. You need to provide the VIN account, can be one VIN account or several VIN account, where is the physical deployment unit is located. The type, this type is important because need to match this other type of the descriptor. It can be shared or not, and the interfaces. And at deployment time, there is a pool of physical deployment units of the same type. And at deployment time, OSM choose one concrete physical data unit based on this type and matching also the interfaces. All the interfaces declared in the descriptor need to match the physical data unit. The physical data unit can have more interfaces not used by the descriptor, but at least all the interfaces in the descriptor need to be there in the physical data unit. Okay, so let's see that in practice. I need to escape, no? Okay, this is the CLI. Sorry, this is the user interface of the OSM. Firstly, this is the bin that we are going to deploy the things. Here we see the client and the BIOS, the physical data center gateway that we simulate using a BIOS. Okay, we have also some black screens. No, I love black screens because they're less dangerous for the site. Okay, this is the OSM client, and here I have the already running this physical element. This is the BIOS. So let's execute, for example, the configuration. Here I can see, for example, the NAT rules that later on, after the deployment, these are going to be changed. Okay, so if we go to the user interface, let's enter. If we go to the physical data units, there's empty, so we need to just create one. For example, here we need to fill a name, a type, select a bin account, adding the interfaces. Okay, as you can see, this is something difficult to replicate and it's easy to make mistake. So I prefer doing this using the CLI of the OSM. So just having a descriptor is quite simple. I know you can see it. I can make bigger. It's quite simple. I just say, okay, this is the physical data unit of the type gateway. This is important. It's in this bin account. This is a list. In this case, one. It's not shared. And this is the interfaces, and this is IP to address. At least the management interface, the IP address of the management interface need to be provided. Okay, so with this file that I have in the history, because I have run just, let me maybe bigger. Okay, OSM PDU create, and this the same file I have shown you. That's okay, and if we go to the user interface, should be there. Okay, when this refresh, this is the PDU I have onboarded. This is the same information. For example, the type gateway. Okay, it's not in use. This is important. In order to make the deployment, let's add also BNF packages. I have already some BNF packages here, but it's not one of my demo. Let's add one using the client. It's quite fast. It's OSM. The command is BNF package create, and the file. The file is an encrypted file that contains all the descriptor, all the artifacts, the chart that is used for the configuration, icons, so on. So it should appear here when it refreshes. No, is this? It is in this case it's a PNF descriptor. I can show briefly. I don't want to bother you because I think Gerardo has already shown this kind of screen, but just say, okay, this is important. Can you see it? Can make bigger? Okay. It's the PDU type is gateway. Okay. Here it is said, okay, for this information I want to use a physical element, not to deploy one. One of the PDU type physical, no? And also we have here the configuration, the information. This is the declaration of all the primitive uses for the configuration. Okay. So let's go back to the BNF. Let's, I need another one. I'm going to use this user interface in this case. Who is this? This contains the BNF that contains the load balancer and the web server. And also let's upload a network service descriptor needed for the demo, who is this one. So it's just by drag and drop, you can show that. I can briefly show it. No? Basically, say, okay, we have two VNFs. One is the web server metrics VNF, is the one that contains the load balancer and the web server, and this other is the PNF, the PNF descriptor, no? And also basically the connectivity of this one. So let's deploy it. Okay, we need to put a name, demo, description, demo. We need to select a VIN. In this case, is the VIN layer 1, 2, 3. Is this VIN here. We need to provide some configuration in order to provide manual, to fix some IP addresses. So just copy paste this configuration, and we just create and start deploying. So after a while, we can see here the virtual machines. This is there are two operations. One is the orchestrator, or create the virtual machines, and another is making the configuration of all the system. And all the system includes the physical data units. Okay, this is a demo, no? It takes some time. Oh, okay. Thank you. It was, I need to log in again to the VIN. Here it is. This is two machines. So we go here. We have that it is orchestrated, and now it's the configuration is running. It takes some time. Okay, let's try to deploy again, just to show you what happens. The same network service descriptor. Okay, with a second deployment. In the same VIM, and also the configuration. Okay, and it fails. Why? Because it says here that there is no PDU of type gateway at this VIN account. Why? Because there is only one PDU. One PDU that is already used by the first deployment and is not shared. I have, when I onboarded this PDU, okay, this PDU is in use, and it's not shared, so it's just used by the first deployment. So normally we will have a pool of PDUs, so this allows several deployments using these PDUs, or having a PDU that is shared. I mean, can be shared between several deployments. Okay, and basically, this concludes the first part of the demonstration of the usage of the physical data units. So it's still running the configuration. So meanwhile, Gianpietro can go on and show you.
Thanks, Alfonso. So the second part consists in showing you what's beyond instantiation. Okay. Oops.
No, we need to.
¿Cómo? Ah. Sorry. Okay, just here. Well, so proxy, this PNF contains a proxy charm inside the package, and it's used to manage some configurations that should occur after instantiation. But in general, proxy charms as I said before, can be complex to build because you have to automate several actions and build several scripts in the format that, that we have available. So what we are, I'm taking this opportunity to describe what we are building to simplify this process. Basically, we are building generators. We call them proxy charm generators, which we expect will dramatically improve the way BNF vendors can manage their day one operations by using simple Ansible playbooks, which is a common way of configuring any system, HTTP requests to consume REST APIs that are already available in the BNF. Even we can go a step further and use the HC standard for BNF management, which is Sol2, a REST API based on Sol2 standard, or generic Python scripts or whatever language they want to use. So the idea would be to, for the BNF vendors to write these other simpler ways to manage their operations, and then we would just drag and drop this in a folder and run a command that automates the building of the proxy charm. So that's what we did here. Let me show you. Here, the folder of the BNF. It contains a folder called charms with a specific charm called BIOS config. And it has a folder named playbooks. And if I open it, we'll find a playbook. And this playbook consists in a set of configurations that will run automatically after instantiating the network service. In this particular case, these actions or these commands will be run over the PNF, that is, over the physical unit. And it's, in this simple example, just a network address translation rule so that traffic can point to the PDU and translate to the load balancer, which at the same time would translate the request to the web server. Okay? So let's see, it says done, so it should have configured already the PNF. Let's switch back to this window here, where we have the VDU. And now we see a destination NAT rule, which was not there before, which will take all the traffic that was pointed to port 80 to the address, this IP address here, which corresponds to the address of the load balancer. So now we will call that day one operation because the service was instantiated, and for it to work, it should touch some things in the environment. In this case, it configured a NAT rule over the PDU, or the physical deployment unit. So now we should be able to point to this IP address here, which is 172.21.7.200, and this would translate it to the request to the load balancer, which is an HA proxy implementation, and then it would translate the request to the web server. Let's see. Okay, there we go. That's the web server that is in this moment running over this server named, well, with the IP address ending in 7, which happens to be this IP address here. Okay? So what else we can do? Here we demonstrated a way of using a simple Ansible playbook to simplify the one operations. We also have a monitoring, we can call a mature monitoring framework in OSM in place, and auto-scaling capabilities. ¿Cómo hago para que se muestre todo? Sí, eso es lo que dice. Okay. I was wrong. Thank you. Okay. So the way this works is whenever a client includes a descriptor containing scaling actions, then the policy manager notices these scaling actions and configures the required elements. Which are these required elements? Alarms with thresholds and monitoring monitoring processes, so that the monitoring module can take into account those metrics and take actions after the threshold, or notify, sorry, after the thresholds have been crossed. So the monitoring module has an embedded alarm engine, so that when the thresholds are crossed, it notifies the bus, and then the policy engine takes the corresponding action. In this case, would be to scale out based on CPU, on high CPU. So the way it scales out is just sends an instruction to a topic where the lifecycle manager is listening, so that LCM can actually create the new instances. So that's what we are seeing now. Okay. So first of all, I will show you the descriptor, which describes what is expected from these scaling actions. Here, the descriptor of the BNF of the web server. And we will find the scaling group descriptor, which basically says, if you go beyond, well, we'll monitor CPU utilization. And if we go beyond 35%, then scale out. If you go below 20%, then scale back in. That's basically it. So that's what the policy engine notices, and then configures those alarms in the monitoring system. But first of all, I'll show you how OSM is now actively monitoring the BDUs that we instantiated. So it's actively monitoring this server. What is left is to start stressing this out. I'm going to access the client. This is the client that is actually here outside. And he will try to stress the server ending in 200. So we will use a tool from Apache called Bench that will send a lot of requests to that server. And now I've noticed that I should have run this before so that you don't have to wait. But I forgot to run this test before. So now we will all need to wait like a couple of minutes for this to go up and scale out. But, well, it will be more interesting that way. In the meantime, I don't know if you have any questions so far. Yes?
Sorry, can you make a very quick summary of the steps taken so far? Like, I mean,
Sure.
Step 1 was this. Instantiation, it's done. Then step 2 is configuration, this is done, this is what was required, and so on and so on, if it is possible.
Yes, I will try to do it with this diagram here. How did you do to make this actually work? Just clicking this? But it takes some time. Excuse me. It's not working. Laptop is fine. Sorry about this. Okay, I will explain it here. Sorry. So, first of all, we have a client already there and a PNF already there, right? It's a data center gateway. It can be a physical router, for example, that we are simulating using a virtual machine with a BIOS software. It's a router. Okay. So what we did at the first action was to instantiate a network service comprised of a BNF containing two BDUs. One is a load balancer, and the other one is a web server. This VNF happens to contain a scaling group descriptor, so that it configures alarms and thresholds so that it reacts to traffic or to any threshold crossed. It also includes a PNF as part of the same network service that can take actions over the PDU that is specified inside that PNF. In this case, that PNF contains at the same time a proxy charm. So if we open the PNF package, it contains a folder with, in this case, an Ansible playbook that will run after this PNF is instantiated. We could also run it on demand if we define it so, because in the descriptor you can define day 1 operations that will run automatically, and day 2 operations that will run whenever you want. We can define both kinds of actions. So first of all, we instantiated this service. Then, since the proxy charm was configured to run automatically, it went and configured the NAT rule over the PNF. At that point, the service is ready and works. And that's where we visited the web service and showed the OSM logo there. Okay. Then we did nothing. We just showed how the web server works and how it's being actively monitored. And the next action we took was to stress the web server by pointing from the customer to this IP address here, which, because the NAT rule is there, it will translate traffic here to the load balancer, and then this load balancer would at the same time translate the traffic to the web server. And since the web server is being congested, the CPU is going up, so it should scale out. And that's what we are going to demonstrate now. So we can see CPU is already beyond 35. It's at 40. So we should see what happened here. OK, as you see now, we have now 2 instances of the web server. And if I refresh the page, well, this is just an add-on. We will see 2 IP addresses here, just for information. .3 and .7, that are the ones that exist here. So here we demonstrated another operation that is useful at day 2, which is auto-scaling based on, in this case, a CPU metric. But it can be activated based on any metric, infrastructure metrics or VNF indicators that are taken directly from the VNF. OK, well, if we stop traffic, then we will see it gets back to, eventually, after some cooldown time, it will get back to the original instance. Any question?
Okay, so can I ask you about the policy here? So I saw your VNF descriptor have criteria. That's your policy definition.
The scaling group descriptor.
Yes. Yeah. So why are you using criteria? Do you have policy model here?
Yeah, we have a policy model, but the first use case that is implemented in this version is just scaling. For release 6, we plan to generalize this for other use cases so that we have a proper policy description and not only the scaling use case.
Thank you.
And when you execute the scaling out procedure and the new interface, new instance of the web service generated, so there are 2 instances of the web service.
Yeah.
So during this period, you should make some configuration to the load balance.
Yeah.
So,
you have options here. In this case, this load balancer is pre-configured. I will show you some insider information.
And my question is, how does the load balance know there are 2 instances of the?
Yeah, I know what you mean. Just to simplify the process, I think this is the. No. Well, I'll explain. Just to simplify the process, the HA proxy load balancer is pre-configured to cover a pool of web servers. So we don't have to configure it over and over whenever an instance is there. But another option would be to use proxy charm and automatically configure it to add the new instance that has scaled. And then if it scales in, it will be removed from the HA proxy configurations, and the HA proxy configuration would reload, and that's it.
Okay, clear. Thank you.
So that's, we saw a scale in there. Because we stopped the traffic, it got back to normal. So just to conclude this demonstration, hopefully this works. Let me see. Okay. Oh, no problem. We wanted to demonstrate some concepts here. So PowerPoint sometimes doesn't work. That's the first conclusion. You have strong faith in. The other conclusions are that, well, first of all, OSM is able to manage both virtual and physical network functions. And this is very convenient because we are working in mixed environments, right? We are not living only in the virtual world. We need to connect things to the real world. So the ability of OSM to orchestrating these automated operations to go and configure physical network functions with configurations that are relevant to the service is a very powerful thing to cover more real world scenarios. Other thing is that OSM is greatly simplifying BNF management, and this I hope this will get better and better as we produce more generators of proxy charms and simplify in general the BNF management process by producing automated ways of just feeding OSM with an Ansible playbook or a Python script or a Bash script or whatever it makes sense to the BNF, so that it becomes a proxy charm so that OSM can easily orchestrate that. And finally, we have a very solid monitoring system that will monitor any KPI that is relevant to the BNF. And first of all, it can be used for the auto-scaling case, but those metrics in the future can be leveraged for other things like placement rules or auto-healing, for example, of network functions. So that concludes our presentation. Thank you. I think we have some room for questions. Yes? Regular what, sorry? Okay. Well, first of all, OSM is expanding so that it can leverage Kubernetes to deploy containerized network functions. So I think, well, it's a fact that OSM covers a much broader space and abstracts the user from the infrastructure, so that we can deploy in Kubernetes deployment and OpenStack, or we can go and control SDN controllers to configure the one interconnections, and those kinds of things. So OSM, I would say, it relies at a higher layer and will abstract the BNF vendor, or in general, the BNFs from the infrastructure. That would be the value. Well, thanks so much.